Okay, guys. So basically, what we want to do today is activity number 2. We have talked about already about the rotation. We did the graphing. Now, what we want to do today is complete activity 2, and activity 2 is the graded one, and the one that I'll be recording. Right, I grade both, but I record that one, and it's basically talking about. Let me share. Basically, gonna be describing transformation. So I gave you guys four right here: 7, 8, 9, and 10. Talk about um, finding the coordinates after the given rotation, and then you have these four, which you are to describe the rule. What kind of rotation is happening in those ones, right? So let's see. Okay, so now what is going to be happening is that I'll be using here the Jamboard to write, and I'll just guide myself from the questions that are in the worksheet. If you guys have the worksheet, it's this one. It's this one. This is worksheet number 2. So then that is the one that you guys should be using. All right, this is the one that we'll be doing today. Okay, so can I go ahead and begin? Should have writing material or
Yes, yes.
something with you. Okay, let me quickly write this right here. So you do need the rules. The rotation for 90 degrees, that xy is equal to negative yx. You need the one for 180, which is xy is equal to negative x negative y. And then you need the one for 270, which is xy is y negative x. So those are what we need to begin today's class. Miss, you're gonna post pictures of working question. The pictures of today, I'm not gonna be posting pictures. It's just gonna be the video because I'm not gonna be graphing anything. So it's just the video that I'm posting today. Yesterday I did post the pictures of the graphs, but I'm not gonna be posting pictures today. Okay, so let me. Okay, right here. So now, if we take a look at the first question that is given to us, it's asked. It has 4 points. So you have point Z, which is -1, -5. You have point K, which is -1, 0. You have point C, which is 1, 1. And then you have point N, which is 3, -2. Right? So these are the first ones, and they're asking you to do this under a rotation of 180 degrees. So now if we go back and we recall what is happening when we have a rotation of 180 degrees, then basically I'm going to have my point xy, and I'm going to change this point to negative x negative y. So now what does that mean is that I am going to be writing the z1, and I need the inverse of the -1 and the inverse of the -5. So the inverse is going to be 1, 5. I have k1, and the inverse of -1 is 1. And the inverse of 0, well, it doesn't have because 0 is 0. So then that would be that. I take a look at C. I have C1. The inverse of 1 and 1 is -1 and -1. And then I have N1. And N, I'm not sure you guys can see that right there. And then N, the inverse of +3 is going to be -3, and the inverse of -2 is going to be +2. So now this is what you guys will need to be writing. Right, I have there. Right? Anybody has any questions with this one?
No, miss.
Clear, miss.
Okay, good. So can I move on to the second question?
Yes, miss.
Okay. So now question number 2, let me write the points. Question number 2 has L being 1, 3, Z being 5, 5, and F being 4, 2. And they're asking for us to do this under a rotation of 180 degrees. Our rotation is going to be XY, my original points, and I want the inverse of these ones, right? And this, I am getting it from the PowerPoint. The PowerPoint that we talked about on Tuesday has these rules. So, what would be my new point for L? What would be my new point for L?
-3, -1, miss.
I'm not changing the place of the number. Take a look at the rule. It says XY, and then I have
-1, -3.
very good. I am leaving it in the same place. It's only the sign that is changing. So I have -1, -3. What about Z?
-5, -5.
-5, -5. Very good. And what about F1? -4, -2. Very good. And then these ones are the ones that I'm going to be writing. Right? Yes? Okay, can I move on?
Yes, miss.
Okay. Number 3 now, or number 9 in the paper, but it's the third one, has S is equal to 1, -4, has W is equal to 1, 0, and has J equal to 3, -4. And this one is under a 90-degree rotation. 90-degree rotation, right? So now if I go back and I take a look at what 90-degree rotation, if I have my original point, it is now going to switch places, and the y is going to be negative now. So that is how I do the conversion, right? So if I'm talking about S1 now, it's going to switch places. I'm going to have -4, 1. But this one is going to be inverted. So now I'm going to have +4, 1. Everybody understood that?
Yes, miss.
Yes.
So
Miss, why did you invert it?
because right here, I have -y. Right? So then now if I do them mathematically, I would have -4, so that it would satisfy this, substituting this into a -y. So because I have the double negative, it becomes +4. Did that clarify?
Yes, miss.
Okay, good. So now if I'm continuing with that idea, I'm gonna switch the places of the other ones. I switch the places because here the places are switched, and then I apply the negative. If I can't apply the negative to the 0 because 0 is neither positive or negative, so that stays like that. But I can apply it to this one, and I invert that, and it's gonna be a +4 now. Right? Any questions? So now what you guys are gonna write is this. Right? That is what you guys are gonna write. Is that one clear?
Yes, miss.
Miss, can I see number 2, please?
Number 2. This one is number 2.
Okay, Miss, thanks.
Number 2, number 3, number 4. Okay, so the fourth one. Number 4. So now I'm gonna write the points. You have V, which is -5, -3. You have A, which is -3, 1. And then you have G, which is 0, -3. And this one is under a 180-degree rotation. And if we recall what is a 180-degree rotation, I have my original points, and the points do not change place, but they are inverted. So both of them are inverted in the signs, right? That is what the 180 states. So if I'm going to be doing that, what is going to be my V1?
+5, +3.
+5, +3. Very good. What is going to be A?
+3, -1.
+3, -1. Very good. And what is going to be G?
0, +3.
0, +3.
0, +3. Very good. And then now this is what I will be using. Right? Okay. Any questions, guys?
No, ma'am.
Okay.
Tell me.
So, Miss, can you please show number 1? Okay, let me go back to number 1. This one is number 1. So those are the first 4, right? So now those 4 basically ask you for the coordinates. What is the coordinates of the rotation? And that is what we showed there. Now, if we take a look at the second part asks for a description of the transformation. So, right now we're gonna see. Let me know when I can move on, okay? Okay. So let me share the worksheet. It's right here. Um, oh, what did I do? What did I do? Um, share this comment. Okay. Um, okay. Can you guys see the worksheet?
Yes, ma'am.
Okay. So This is the second part, which says write a rule to describe a transformation. These are the four that we just did right now that ask you for the coordinates. So now these are the transformations. So now we're going to work with number 11. We want to take a close look at this diagram. Now, these are very, very easy to do, right? And I'm going to show you guys a trick on how to do this. You could one, and this is the logical theoretical way. You write the coordinates of the picture in black and you write the coordinates of the picture in blue, and then you take a look at the rules and you see which rule gives you those coordinates. That is theoretically how you would do it. The fast way to do it now is you look at the diagram and you see how many jumps did it make. How many jumps did the black image make so that it goes into the blue position? If I take a look at number 11, see the position in where the black image is, and you see the position where the blue image is. How many jumps happen? Anti-clockwise. Anti-clockwise. Anti-clockwise means that it is going like this. It is here when it makes a second jump. When it makes its first jump, it will be here. It makes another jump, it will be here. And when it makes another jump, it will be here. So how many jumps happen?
3 Miss.
3.
3. If I take a look at the degrees, 3 jumps, does that mean 90 degrees, 180 degrees, or 270 degrees?
270 degrees, Miss.
270 degrees. Very good. So for this first one, the rule that we are going to be writing, a rotation of 270 degrees counterclockwise. A rotation of 270 degrees counterclockwise. You guys do the little degrees because I don't see that on my keyboard. So then that is what you would write for number 11. That's all you would write. A rotation of 270 degrees counterclockwise. It's just asking for the rule, right? Description. So that's all we need to write. Yes? Everybody understood that
Yes.
one?
Here, Miss.
Okay, good. So let's take a look at number 12. If I am moving counterclockwise in this direction, take a look at my image in black, my original image, and it's in the blue position now. That's my rotated image. How many jumps happened here?
2 Miss.
2.
2. How many degrees would that be?
180.
180. Very good. So my description would say a rotation of 180 degrees counterclockwise. And then that would be for number 12.
Yes, meaning that not just the answer.
Yes, what I'm putting in the chat, that's the answer because this question only asks you guys for a description. So you look at the diagram and you see what kind of rotation happened. So we're basically doing the opposite. Instead of them giving you what to do, they already did it and they're telling you, now tell me what happened here, right? So if we take a look at number 11, a rotation of 270 degrees happened because there was a rotation of 90 degrees 3 times. If we take a look at number 12, there is a rotation of 90 degrees 2 times. It jumped 2 times. That's why it went from the black to where it is in blue. So that's why it's a rotation of 180. So now when you guys are writing your responses, if you guys are writing it in your notebook, then what I am putting in the chat, then that's all you will need to put. If you are writing it in document, the same thing. Under each picture, you will write what I have in the chat. A rotation of 270 degrees counterclockwise, a rotation of 180 degrees counterclockwise. That's all you're going to be writing. Did that clarify?
Yes, miss.
Yes, miss. Clear.
Good. Okay. So let's take a look at number 13 right here. Counterclockwise. Remember, rotation only happens counterclockwise. So, how many jumps happened in this one?
2, miss.
2? Okay.
2, miss.
2. Very good. It was here. It did its first rotation over here, and then its second rotation over here. So it's 2 rotations. How many degrees would that be?
180.
180, miss.
180. Very good. So that one will be a rotation of 180 degrees counterclockwise. And then number 14, if we take a look at number 14, how many jumps happened in that image?
2. 2, miss.
2 as well. Very good. It was here in the black position first. It did its first jump here in this quadrant number 3. And then its second jump, it ended up in quadrant number 4. So that's a total of 2 times 90. That gives you 180. So then for that one, it would be a rotation of 180 degrees counterclockwise as well. Anybody has any questions?
No, miss. Clear.
Everybody understood this topic. I think that rotation was a little bit more clear than reflection last week. I think if I would give you guys a test on reflection, I don't have high
Out of it.
hopes. I don't have high hopes for that. But I think you guys understood reflection a little bit more better this week, right? You could do this on your own if I would ask you guys to do that. So, this is the end of rotation, guys. Next week is our last week in this unit. We're going to be doing translation. Translation is like sliding. Remember when we did symmetry in 3 weeks ago? We did symmetry. There is a gliding symmetry, so that is translation. That's what we're doing next week. You need graph paper for next week as well. And we will basically be doing the same plan that we did this week. All right. And then that will be it. After next week, you just wait patiently for your grades. All right. Anybody has any questions?
Miss, when will issue grades, miss?
When
Like,
will
what
we
date?
Okay, let's see. Let me look at my calendar. Okay, I will stop recording first.